The STOE model posits the bizarre features of the quantum mechanics model of the small scale should have analogies in the classical scale. One such feature of the quantum model is the model of spin 1/2 observations of the Stern-Gerlach experiment. This is the experiment. In the original experiment, silver ions with one free electron was sent through an inhomogeneous magnetic field. What resulted was 2 dots. The quantum mechanics model of the Stern-Gerlach experiment is that the magnetic field exerts a torque on the magnetic dipole of rotating charged elementary particles. This presumes each particle has only one north-south magnetic field fixed by the rotating charge. The magnetic moment vector will precess about the direction of the magnetic field. The non-uniformity of a magnetic field induces a sideways force on the particle. Thus, you get 2 dots. This can be depicted as the electron having 2 spin axes in a heterogeneous magnetic field that cannot be measured simultaneously. The accepted interpretation is that the photon, neutron, electron has a mechanical spin. The mathematics used assumes an angular momentum describes the results. This, of course, is contrary to what the STOE assumes. The classical expectation of the Stern-Gerlach experiment is that a random thermal effect should result in a random space orientation of the particle's magnetic moment. You will note there's an assumption here that the particle really can spin in its movements. Therefore, a line should be projected on a screen. However, the observation for electrons has 2 points on the screen that Hume argued for a quantized space. Then the interpretation problems become weird. Another problem is what constitutes charge, and where does charge come from? Charge must be related to structure of elementary particles. The photon and electron must have some relation to Maxwell's laws. The polarization of photons in a magnetic field suggests the photons are magnets. The photon acts like a magnet. If no other fundamental particles are to exist other than the plenum and the hods, the hod produces magnetic effects. One side is the north pole, the other side is the south pole. The column, which is a photon, is a magnet that carries the electromagnetic field. The STOE suggests there is no real intrinsic mechanical spin. You remember that the electron is going to be oriented to the minimum surface area of the hods that's presented to the direction of movement. This prevents a mechanical spin as the electron moves. So the only thing we have left is the reaction of the magnetic poles to the magnetic fields. However, the magnetic poles of particles do interact with the magnetic field to produce precession. The other force vector being that of the particle trying to get the minimum surface area presented to the direction of movement. So here you see it. The digitization of spin is easily explained by classical arguments that the magnetic poles of the assembly of hods cause the unique directions. That is, space quantization is unnecessary. The experiment uses assemblies of magnets to show how the electron model moves through an inhomogeneous magnetic field. You remember from the structure of the electron that there are 4 poles which could orient with the north direction on Earth if they are in a floating water, if they're floating. So here we have the electron or positron suspended by a string and an inhomogeneous magnetic field. The minimum surface area is presented to the direction of motion, which is down. When it gets close to the magnet, the particle begins to spin as the magnetic force starts to move it. And here it is, it's spinning still and it's oscillating like that. So it's oscillating around one pole first, then it goes to the other pole and then back. This is like a figure 8. That's to say, to get back to one given direction takes 720 degrees of movement. That is to say, it has a 720 degrees symmetry. The other set of poles has the same kind of thing as it swings. The STOE proposal is that the hod has a magnetic field rather than a rotating electric field. And that's what causes the observation. Other quantum mechanics bizarre features explained by the STOE are the wave-particle duality, that is to say, it is not wave-particle duality, diffraction and interference, entanglement, the photon is a particle, polarization, inertial, derivation of the equivalence principle, and photons and neutrinos have greatest speed of particles because they present the minimum surface area, no surface area, to the direction of motion. STOE also explained many cosmological mysteries in these videos. This is all very conceptual. For a century, physics of the small has been math first, interpretation second. Math first has resulted in bizarre quantum features which make no sense, and therefore the statement, do the calculation and forget about the conception. Perhaps physics should turn to conceptualizing first as a reality principle, and its corollary, the fractal principle, suggests. A core feature of the quantum mechanics model is the model of spin 1/2 observation of the Stern-Gerlach experiment. The STOE model of the structure of electron using disk magnets as an analogy of how it suggests multiple north-south poles produce the, quote, spin observations. There is no spin. The electron analogy was placed in an inhomogeneous field, magnetic field, and the change of orientation is photographed. Noting that the reorientating always occurs implies no electron will travel straight through the magnetic field. Thus the STOE model, another quantum feature. This is the paper describing the experiment in more.